Welcome to all of you. Hope you are enjoying this holiday. Now, for your semester, myself will be taking some part of the syllabus, that is thermodynamics. In that thermodynamics, the first chapter is heat engine. Now, before dealing this directly, we should know some fundamental things. We have studied somewhere P, V, and T. They are thermodynamic coordinates. Thermodynamic coordinates means what is P? P is pressure, V is volume, T is temperature. If any one of these three changes, other two automatically changes. Because of that, they are called as thermodynamic coordinates. P is pressure, V is volume, and T is temperature. You know, for a perfect gas, this equation holds good. PV is equal to RT. Perfect gas is an ideal gas, Means we can imagine that perfect gas or ideal gas which follow this equation. But in the universe, that perfect gas never exists. See, consider certain gas is present inside the cylinder. Its temperature is T. Pressure on the surface of the wall is P. And volume is V. If temperature of this gas goes on increasing, then expansion of the gas takes place. Expansion of the gas takes place means the particle exerts certain pressure on the wall and volume increases. If temperature decreases, that other two also decreases. Then, under this condition, we should know what is isothermal process and what is adiabatic process. What is isothermal process? Consider this is the gas is present here. So the temperature is about 100 Kelvin, temperature of the gas. If you go on supplying heat energy to this gas, what happens to the temperature? Temperature goes on increasing. Then I don't want that change in the temperature. The temperature should not increase or should not decrease. What varies? P and V changes, but temperature should not change. If you compress this, volume decreases. If you take it away, volume increases. But I want this temperature to be constant. If these changes in the gas are taking place, by keeping temperature constant, that process is known as isothermal process. Then how to keep temperature constant? So if you are compressing this, say temperature is increasing 100, 103. By some means you take heat away from the system. If you take heat away from the system, temperature remains constant. So if you are moving this piston in the upward direction, due to expansion, assume that temperature is decreasing. Say it is 90 or 95 like this. But again you don't want decrease in the temperature. So for that what you have to do? Supply heat by some means to the system. In other words, let pressure and volume to change, but temperature should not change. To maintain that, either you supply heat to the system or you remove heat from the system. This process is called as isothermal process. And what is adiabatic process? Now this time you don't worry whether the temperature increases or decreases, but care should be taken that no heat should enter the system or no heat should come away from the system. So if the pressure and volume are changes taking place in this manner, that means temperature also should change. Then this process is called as adiabatic process. Remember that in isothermal process, temperature does not change. To maintain this isothermal process, it is allowed heat to enter the system or to heat to come out from the system. But in adiabatic process, pressure, volume and temperature, all the three changes, but care should be taken that no heat should enter the system or no heat should come away from the system. This is your adiabatic process. Now coming to this first chapter of heat engine. So who has imagined this heat engine? First, what is that heat engine? Heat engine is a device which converts heat energy into mechanical energy or heat energy into mechanical work. It is one device which converts heat into mechanical work. Then Saudi Carnot, who has imagined first heat engine, and see, he has conceived that engine theoretically, that he has imagined that engine theoretically, which is free from all the losses and should have maximum efficiency. He has imagined theoretically, not practically. He has not constructed engine, but on the paper theoretically has imagined an engine which is free from all the losses. Means, say you are supplying amount of heat about 80 joules to one particular device. That device converts that entire heat energy into mechanical work. If all this 80 joules is converted into work, that means heat energy is not at all wasted. There is no loss in the heat energy. But you know, machine means it rotates, engine means it rotates. Friction occurs. There is always some loss. See, by giving certain 80 joules of heat to this device, if 60 joules of work is done, 60 joules of work is done, then here amount of loss of energy is 80 minus 60. This is 20 joules. But Carnot has engine, there should not be any loss. And that any engine should have greater efficiency, maximum efficiency. What do you mean by efficiency? So efficiency is amount of work done divided by amount of heat supplied. Amount of work done and amount of heat supplied. If work done in the first case is 80, amount of heat supplied is 80, then this is the maximum efficiency. Very good engine. In the second case, say work done is 60 joules, amount of heat supplied is 80, so this is less than 1. So practical all engines have efficiency less than 1, but Carnot imagined engine has got efficiency is equal to 1. It is a maximum efficiency. Then what are the different parts in the imagined engine? So Saudi Carnot has imagined an engine. His engine consists of 4 parts. One is source, which is maintained at very high temperature. Maintained at very high temperature T1. It has infinite thermal capacity. It is provided with an insulating sides, but only top it is conducting one. What is conducting and what is an insulating? If any instrument or any material conducts the heat to flow through it, that is called as conductor. If any material which does not allow the heat to flow through it, it is called as an insulator. Take one wooden stick and one is steel, keep both of them in a fire. Then the stick which you have placed, which is made up of metal, you are going to get heat. That means heat has reached from one end to other end. So it is called as conductor, and another one is insulator. So there are 3 methods of transmission of heat. One is conduction, convection, and radiation. So conduction takes place, the transmission of heat inside the solid material, means particle to particle heat get transferred. It is called as conduction. If you take one metal stick and keep them one end in the fire, the heat is transmitted from this end to this side. It is called as conduction. What is convection? See, if the heat transmission takes place due to the motion of the molecules in a liquid, then it is called as convection. The molecules takes the heat from one place to another place inside the water. This is called as convection. And the radiation. So we are getting heat energy from the sun to the earth by the method of radiation. Means the transmission of heat from one place to another place without affecting the intervening medium is called as radiation. Okay. So Carnot's imagined engine consists of 4 parts. Among one is source. Source has got a very high thermal capacity. It has maintained at constant temperature T1. Constant temperature. It has got finite thermal capacity. If any amount of heat is taken from this source, then the temperature does not change. So it is provided with the 3 insulating wall and the top surface is conducting one. That means heat can flow only through this, not through these 3 sides. And another one is sink. So sink has also at a constant temperature T2. It is also of the high thermal capacity. It can absorb any amount of heat. Then its temperature does not change. The construction is same as the source and the sink. Means this source rejects the heat and the sink receives the heat. By the rejection, its temperature does not change. By taking certain amount of heat, its temperature does not change. But here remember that T1 is greater than T2. And the third one is a cylinder. Cylinder is provided with one piston here. Side walls are insulating in the cylinder. Bottom is conducting one. It is filled with a perfect gas. It is an ideal engine. Perfect gas is an ideal gas. It's theoretical how engine may be. Carnot engine has imagined. So this is working substance is nothing but here in the Carnot engine is a perfect gas. And lastly, so it has a stand. So in that stand, this cylinder can be placed and we can process adiabatic or isothermal expansion and contraction. So process of adiabatic and isothermal expansion and contraction takes place on this stand by keeping cylinder on the stand. See, when this working cylinder is placed on the source and piston is moved in the upward direction, then this is conducting one and this is also conducting one. Amount of heat enters. Less amount of heat enters the system is H1. And after that, this cylinder is placed on the sink. First, this was placed on the source and after that it is on the sink. And amount of heat rejected to the sink is H2. Then you know that work done is difference in the, this is H1 minus H2. So amount of heat absorbed is H1 and amount of heat rejected is H2. Work done is H1 minus H2. So your efficiency can be written as eta amount of work done divided by heat supplied to the system. It is H1. Heat absorbed is H1. Amount of work is W. Then this is, what is W? H1 minus your eta is H1 minus H2 divided by H1, or your eta is equal to 1 minus H2 upon H1. As we know that H is proportional to T, means what? If amount of heat supplied increases, temperature increases. If amount of heat supplied, if heat is taken away from the system, temperature is decreased. So on the basis of this, I can write one more expression for eta. Your eta is 1 minus, in place of H2 it is T2, in place of H1 it is T1. You remember these two equations, they are same. So efficiency is given by 1 minus H2 upon H1. What is H2? H2 is amount of heat rejected to the sink. H1 is the amount of heat absorbed from the source. So T2 and T1, so they are decreased and increased in the temperature.